afternoon. Today, in the cycle of talk of the Sanka Chair of Nanotechnology, Thursday NanoSpin-off talks, we have the pleasure of presenting the company SIMUNE with talk Science to Industry. SIMUNE is a software company that develops scientific software solutions based in atomistic and quantum mechanical approaches. SIMUNE has the mission of bringing or facilitating this type of first principle calculation into industrial or even academic environment, not specialists in this field of ab initio calculation. Today, we have with us the CEO of SIMUNE, Daniel Simo, who will talk to us about his user-friendly ASAP software environment and will illustrate us with real application examples. Thank you, Daniel, for staying here with us. The microphone is yours.
Thank you. Thank you. Good afternoon, all of you. Thank you for giving us the opportunity to be here today and share with you our company and the activities, and as well as our products. I would like to focus on this presentation, as the title indicates, to the challenges of having a company devoted to nanotechnology, and particularly bringing all the scientific findings to industry in the form of products and services. This is not easy sometimes. So to start, we'll talk about SIMUNE and how it was created, where it comes from, and what it does do actually in a day-to-day basis. SIMUNE was launched in 2014 as a joint venture from a group of world-known scientists and experts in nanoscience. Most of them belong to the CIC Nanogune, where we're hosted. I am today sitting at SIMUNE's offices in San Sebastian. And our company supports close collaboration with academics, as you can find in our webpage. There's a lot of projects, and just being here at the research center exposes us to a lot of different projects in common with academics. So this is one important part of our company. We do create scientific commercial products. And obviously, we are devoted to any technology and tools for science related to nanotechnology. So I'll go ahead and continue with the presentation. So the title of our presentation today is Science to Industry. And like I said, because of the nature of our company and our activities, it does put us a little bit more on the spot than any other company. I think that there are many companies out there that use nanotechnology as the core to their products and their business. However, in our case, it's a little bit more particular and significant, since everything, absolutely everything that we do is related to nanotechnology. We do help industry to do different things with our tools in the context of viewing things in the nanoscale. As we say around here, nanotechnology is the big challenge of the small. And that makes a lot of sense. The outline for today's talk, we will talk about SIMUNE a little bit. We will talk about our services and products. We'll talk specifically about ASAP, the Atomistic Simulation Advanced Platform, which is pillars for our product line. And we'll talk a little bit about our product, our projects, and the evolution of the company in the past and future. So as I said, our company is located in San Sebastian. You can see this picture here with the beautiful beach of San Sebastian. This is actually a good selling point when we try to acquire new talent to come and have them live here in San Sebastian. We are a spin-off from the research center, CIC Nanogune, and that means that our majority shares in our company today belong to the research center. The rest of the shares are held by the scientific board, and we will get into the specifics in the next slide. You see here our core team. We do have some other people around, but this is basically the management lineup of people. As you can see, all the different sides of the company are represented here, and on the left and on the right, you can see the scientific board. These are the people that actually created our company initially. There are shareholders and contributors from a scientific standpoint. We'll continue now with basically our stand in international market player. We, as you can imagine, deal with larger companies. It is only the large companies that can afford to invest in research and development for things as complicated as nanotechnology. We do have then agreements with some industrial collaborators such as NEC, Merck, Infineon, Repsol, JSOL Corporation in Japan, and even Gaussian, which are other creators of scientific software. As you can imagine as well, we do have partners that are in the academic side. And you can see here, the MAX initiative in Europe is quite important. You may not know about it, but high power computing, which is required for advanced scientific tools, and we'll talk a little bit about that. The Siesta group, Siesta is an open source initiative that actually some of our founders, our company founders, are the authors of this BFD tool for atomic structure simulation. You can see the CCAM, ASC as open source scientific software, Massachusetts Institute of Technology, MIT, and many others that are not here in the picture. So we'll continue here. We'll talk directly about our products. Our product lineup today is limited to those that you see here, but in parallel, we're always working on development for new things. A little bit more in progress, but they're all related to the same thing, nanotechnology related tools for scientific approaches to developing new products in industry. Later on, we'll see how we focus in application-specific solutions for industry. However, we do have a lineup of products that are geared towards academics, and we'll talk about that briefly as well. So to start, in general, scientific software production for modeling materials and properties at quantum mechanical and atomistic scales. Now, ASAP, Atomistic Simulation Advanced Platform, is basically a workflow and the base to host calculators and enable them to communicate with other parts to make easier the pre-processing, post-processing, and analyzing the results. We'll talk a little bit more specifically about the functionality and the advantages of using our software, in particular, generically. Now, Siesta Code is the Spanish initiative for atomic structure simulation. Again, our founders were the authors of the code, and we still today exist as a very powerful code. We'll talk about that. Basically, Siesta is pretty unique in the sense that it can tackle large systems with thousands of atoms, which you can imagine it requires high power computing. This is another side of our business that we'll talk about. Siesta also supports linear scaling, which is one of the later functionalities, which sets it a bit apart from the rest of the competitors. Now, Siesta-related products are pretty much every small tool that is required around the Siesta code. We talk about pseudopotentials, bases, set library, tutorials, very important for academics. Also, we have Trans-Siesta. Trans-Siesta is devoted to quantum nanotransport in Siesta-based solution for the calculator. And it is used mostly for the electronic industry to analyze electron flow and properties of conductivity of the material. And it's also molecular nanotransport, but it does work along with Gaussian. We're currently about to release a software tool and integrate it into Gaussian. We have recently closed an agreement with Gaussian. We're also distributors of Gaussian products as well. XChem is quantum chemistry solution for photoionization processes in the time domain. This came out of the university, the Autonomous University of Madrid, the UM. And Sirena is our own product that we have developed to avoid challenges and complexity in deploying complicated and let's say, very extensive scientific calculator software for servers. As you can imagine, when you have high power computing, sometimes it's distributed. You're looking at a cluster of services. We're using thousands of CPUs during weeks at a time to get a single result. and deploying the software to the servers the first time around, and then managing all the jobs in the queue for the calculations can be quite a bit complex. It does require specific environments in the servers, and that usually requires the scientists to have IT support. Well, Sirena is our solution to that problem, specifically for new users and users that are using clusters, different clusters at different times. We'll continue here with our services. As you can imagine, it was only possible for us to develop this kind of tools with the expertise that we have acquired in the scientific side of things. So our knowledge and our skills in approaching different problems and creating the calculations that will yield results that are valid for industrial applications require a lot of knowledge. And so we sell our knowledge in the form of consulting services. We do have, in the past, I've worked for many different companies. However, this is precisely why we created this set of tools, so that some of the knowledge of software tools from an IT side will not be required, so people can focus on the science and the objective of the simulation and the calculation, and they will not require consultant services every time. When problems are, that is the calculation or the material properties that we want to take a look at are complex, then even with the most advanced tools, it may require some consulting services and some help in creating and setting up the simulation. And we'll talk about this because one of the most important things about using these software tools is setting up and creating an input file properly, so that the results that we obtain are faithful to the objective we're looking for. As well, interpreting the results become a very important part of the whole process. You can get some values as a result, but you always have to put them in the context of what you're looking for, exactly whether it's academics or industrial objective. So SIMUNE also provides scientific consultancy services, and again, in the same context as we sell our products. Now, customers paying this from a business standpoint, when we think about what we can offer to the market, usually we look for the challenges, hence the pain, that the customers encounter in using specific technology. When we talk about nanotechnology, we take a look and see where companies find obstacles in developing, getting enough information to develop their products. And this is where our tools and our expertise can actually reduce costs. Reducing costs can come simply from the fact that you do not need to go to the lab and do experimental tests. Rather, you can recreate and model different structures and look at their properties. So when you do go to the lab and you create prototypes, the findings will be exactly what they showed in the computational modeling phase. So as you can imagine, manufacturing has become quite a precise process. In fact, it gets to the point where traditional and standard tools in macro scale are not capable of offering a competitive advantage to companies. So most high-end companies are turning to nanotechnology as an answer to give them a competitive edge. And this is where SIMUNE can provide all their products and expertise. Novel materials, as you well know, because some of your students and scientists, everything we see and touch is composed of atomic structures. So no matter what the industry, in some form, being able to design a new material will have consequences in the products they create. So this is a good thing for us because we can tackle different industries because of the properties or the challenges that they find related to thermal, chemical, optical properties can be solved by looking at a nanoscale to the structure. So modeling with highly accurate transferable quantum mechanical and atomistic methods enable all the different companies to save on testing, create new materials, and effectively saves time and money, as you can imagine. And most importantly nowadays, it shortens the time to market. We all know how the phone companies are obsoleting new models every year. They're running even faster to adopt new technologies to offer a competitive advantage. And we all know that most of these technologies come from all the work, scientific work that is done by looking at materials and behavior at a nanoscale. So this is very important. Now, let's talk a little bit more specific about ASAP, or Atomistics Simulation Advanced Platform. The acronym obviously has a double connotation. Our idea was that ASAP will enable companies to go quickly adopt nanotechnology approach to their new product development. So aside from being Atomistics Simulation Advanced Platform, we also want to send a message. This is what enables quickly using this technology to create new products in industry. So ASAP generically is a universal platform for modeling materials and properties in a quantum mechanical atomistic methods. So basically, ASAP is very modular, very fast. It can handle large demanding systems, and it does provide AI-assisted automated modules. Now, this is obviously in the context of more basic simulations. Very advanced simulations sometimes do require human intervention previous to the simulation. Now, the kind of applications that ASAP could be used for, as you can see here, is to study molecules, bulk surfaces, nanotubes. We also look at interfaces between materials, 2D systems, electronic properties when we talk about transistor, magnetic properties, optical properties, mechanical properties, charge transport catalysis, defects even. And all those different applications do correlate to industries, the chemical industry, the energy industry, automotive. Automotive is one of our big clients, electronics, biotech, you name it, really, it can be looked at from a nano standpoint. So it's quite versatile, our tools. And again, ASAP as such is a universal platform. And then we'll talk a little bit about the calculators. More specifically, the features that it offers compared to some of the other products that are available in the market. It would be a flexible environment for advanced material design. We do use Siesta as a core calculator. We do use others, but particularly as a solver to calculate material properties. We can automate workflows. It is a modular approach, and modular approach not only serves in terms of specifics of what you need, but also in the commercial side, it enables us to not penalize in cost to customers that only need part of it and not the whole thing. So it is flexible, using different modules that are customized for specific problems. We do provide a graphical user interface. I think as students, you might have found out that a lot of the tools that are available to the scientific community, as powerful as they are, sometimes they're complex to use. They're very complex to use, not only because of the actual use of the tool, but the setup of the tool. If you need to compile an executable before you can run the software, that presents a previous problem that requires some knowledge of IT. If you're not familiar with an input file that you need to feed into the calculator, it helps a lot, obviously, to have a user interface that explains what each one of the parameters does and how it influences the outcome. Also, with artificial intelligence, we are able to help the user if we get a little bit of context of what they're trying to achieve in making sure that the simulation is set up properly and efficient. So there are many different features that we offer within the platform. Now, Structure Builder is obviously for molecular cluster nanostructures database where you can basically pre-select the type of structure that you want to work with. And you do have an interactive geometry builder in 3D that you can watch and modify. We also have a control for local and remote server calculation. So we talked about how important it is when we use scientific tools, and the larger the system, the more atoms that we want to include in the system that we want to model, the more computing will require. And now we're talking thousands and thousands of CPUs. Now, fortunately, computer is advancing to the point that what was impossible to be done 5 years ago today is feasible within a few days or a few weeks, worst case. So there's a lot of things that we can do today that it was not possible 5-10 years ago. So this is something that has changed in the business. Now, multi-platform, obviously we do support all different operating systems. As we know, the customers are using different things. Here, pretty much the most common operating system is Linux in the server, or any flavor of Linux that you may on the server side, but we also do have the workstation side of things. So obviously we provide the graphical interface to be ran locally in different platforms. As well, we do offer an executable of the calculator to be run in the local workstation. As today, workstations are growing beyond 24 cores, they're powerful enough to be able to create some properties. We'll talk about interfacial energy tool and some other products that we offer that are feasible to be run in local workstations. And this is also important from a client standpoint. When we talk about the graphical interface, here we're trying to show you a little bit what it looks like. Basically, the different screenshots that we have for the different parts of the workflow. You can see here the libraries that we have, the structured builder, how the next step with the artificial intelligence assisted input creator, as we talked about, and the output analysis, quite important. And this is something that we're always working. This is a continuous development because new applications are adopted into our software, industrial applications, and those require specific analysis after the calculation. Talking about industrial applications, there was a video there, and I'm gonna negate it because it's just basically more screenshots of the software. You can actually go to our website and see specific use cases, tutorials, and videos about it. But I did want to say that our main focus is in industrial applications. I mean, after all, science yields the results that are adopted by industry. And this is really why today's talk, I chose the title of Science to Industry, because not always scientific findings can be brought easily to industrial applications. This is one of the challenges. It's very difficult to have the vision of how academics or research can produce things that are immediately usable in industry. Sometimes they're intermediate steps. Sometimes the link is not so obvious. And this is part of our challenges as a company. This is actually one big part of the time that we spend every day is basically looking at different applications, industrial applications, and how those relate to specific scientific findings. It's not obvious, and sometimes it requires a lot of work to make it usable in industry, even though it has already been proved in the scientific community to be quite useful. So this is one good part of our dedication in a day-to-day business. So we do have a couple of examples. I'm not sure if the font here is a little too small for you guys to read. In any case, all of these are available on our website, and you can, same thing here. We can talk about bio applications, catalysis, as I mentioned before. Nanotech can be applied to just about any industry. We do focus on all of those that are most profitable for us, those that are most competitive, those that have obviously large amounts of money devoted to R&D. And this is only a logical approach from a company. Now, our evolution, the software evolution, as I said, I mean, ASAP is not a product that is static. It is a continuous development effort. The more we talk about clients in different industries, the more we find challenges that we can answer to with our tools. However, we do need to create the code corresponding to those. Now, SIMUNE is devoted 100% to our base platform, which is ASAP, to implement different features demanded by industrial clients. But nowadays, we are approaching this with a little bit of extra technology, as you probably know in different industries. Artificial intelligence and machine learning are very useful things when you need to handle a lot of data. It becomes quite difficult to have all different scenarios covered in large database. And so artificial intelligence, machine learning are key components of software, and we do see that this will be a continuous development. Cloud technologies as well. A lot of people are going to a computer server free environment, so they do use computational resources in the clouds. However, I also have to say that most industrial clients are quite reluctant yet to use cloud services. And you can imagine confidentiality is one of the problems, and fears that the information may get to the competitors' hands. And this is more so in specific markets. For us, Japan has been our main market in the past for 5 years now, because they're the most demanding. They have very demanding industry. Asia in general, as you can imagine, companies in automotive like Honda, Toyota, LG in Korea, Hyundai, which do offer solutions for industrial applications. They're not very comfortable, a lot of these players, with computing on the cloud. However, we know that eventually this is going to be something that most people will be using. In academics, it makes a lot of sense. So this is, high power computing is very expensive in terms of equipment. So not everybody can have a large amount of servers and CPUs available to them locally within their company. So this is also something we're developing along with everything else we talked about. Well, finally, this slide looks a little bit messy because we're trying to link the different products, the actual product names that you see at the top in different colors, to specific industries, okay? And sometimes it's not so straightforward, as you can see. So SAP molecular dynamics engineering, you can see that it approaches different sectors as chemical, automotive, biotech, pharma. They're very competitive industries. ASAP interfacial energy tool is more specifically chemical and automotive related. ASAP electronics, obviously that's a pretty wide scope. Electronics industry, chemical as well, believe it or not, and energy in general. ASAP chemistry, obviously in pretty much all of them. Transport as well, it's related to electronics and even biotech and pharma. And cloud is a more like transversal common technology that we will be using to apply to all the different applications that we covered. So at this point, I would like to talk just a few minutes about the education side of things. I think it makes a lot of sense today that we talk about this. In our minds, we would like ideally to companies, industries to adopt nanotechnology. The complexity and the knowledge required up to date has been a challenge for companies to acquire talent to be able to use these tools effectively. And this is where you guys come in, basically. We believe that if academics would put a little bit more focus on using commercial tools, and I know they are, okay? I'm not saying they're not, but this will yield better results for industry down the road. Obviously, from a company standpoint, we would like to be present. We would like our tools to be known. And this is why we decided to spend a significant amount of time in our company to create different packages for academics courses. Basically, we're trying to see if we can sync curricula specific in specific universities to cover all the different aspects of the complex requirements that theoretical and computational chemistry or physics can bring to the industry. So in this sense, ASAP is being conceived because of our nature and where we come from. Our involvement with academics and scientific community has provided a unique an advantage in creating tools and materials for education purposes. And that includes all the software for system design, performing the calculation, and all the automated post-process. And we're hoping that at some point this year, we'll be able to have some actual live, real use in the academic year in some universities. So the students will be able to get some practical skills in modeling materials and getting the properties using the methods of quantum mechanics. So we are hoping that slowly but surely and progressively we'll be able to help in you guys learning how to perform quantum mechanical calculations, and more importantly, how to interpret and get the data out of the results of the simulation. So yeah, this course does include theoretical background and practical parts. So I think that this is something that should be a good, important part of the work we're going to do this year. So basically this will pretty much, I think we're maybe 5 minutes extra, but I would like to devote some time to questions, and that will conclude our talk today. So I'll go ahead and give it back to you.
Thank you, Daniel. We start with the question from the students. You have questions?
Hello. What program do you use for all of these things?
I'm sorry, let me turn up my volume. I can't hear the question.
Daniel, can you stop share the presentation?
Yes. There we go. Okay.
You can see it better. Oh, thank you.
¿Qué entorno es el que usáis para obtener todas estas datos?
Monica, can you take that? I'm not sure if...
No estoy segura. I don't know, sorry if I understood the question. Can you repeat it?
I couldn't hear it either.
¿Puede repetir la pregunta? No sé.
Yeah, Monica's asking if you could repeat the question.
Sí.
I think the connection was breaking up on you guys' end, because yeah, I can see Monica and I can hear her perfectly, but you guys are frozen and I cannot hear you. Nos hemos perdido, ¿no? A ver si vuelven ahora. Okay, you're back.
Sorry, Daniel. Can you hear me? Ah, thank you.
No, we had lost you for a minute.
Yeah.
We can hear you. So can you repeat the question?
Yes, we missed the connection. Oh.
Now I can hear you.
Okay, can you hear us?
I think so.
Nice.
Yeah.
Nice is fine.
And it's breaking up again.
Please.
If you work in Python, Java, C, or
Okay. Okay, that's an easy one. No, I think I got the question. I don't know. Can you guys hear me? Okay. Okay. So
we are writing the question.
no, I think I got that. He was asking about what
Now
kind
you
of.
can hear me?
Yeah, I can hear you. Yes. Can you hear me? Is the question.
Espera, es que vamos a hacer una cosa. Vamos a cambiar una cosa.
I can hear you fine right now.
Porque se las...
If you want, I can answer the question if you can hear me. No, they're frozen again. Right. Mónica, ¿y por qué no está el PPT ya? Ha desaparecido, ¿no?
Madre mía. Qué pollón.
Hola, Daniel, ¿nos oyes ahora?
Sí, sí, sí.
Pero nosotros sabemos. Ah, mira.
Os oigo, perfectamente.
Ahora, a ver,
Ahora, Daniel.
Sí, os oigo perfectamente.
oigo perfectamente.
Sí.
Pero a nosotros a él, ¿no?
Dale al micrófono.
Sí, yo tengo el micrófono abierto, sí.
No pasa nada, ¿eh? Momentos de publicidad. Nos están escuchando, vale.
Ahora.
Sí, te oímos,
Si no ponemos el sonido aquí y voy yo con el...
Estaba muteado. Hola, Daniel.
Sí, os oigo perfectamente.
Es que a ti no te escuchábamos.
Perdón, que...
Nada, o sea, yo preguntaba en qué lenguaje de programación trabajáis, Java, Python, C o cuál.
Sí, bueno, efectivamente, os iba a explicar. Utilizamos, como podéis saber, en la parte del calculador es Fortran, ¿vale? En la parte de siesta. Nosotros en nuestros productos utilizamos principalmente Python, ¿vale? Pero quizás voy a dejar si Mónica quiere añadir algo a esa pregunta, que es mi científica jefe.
Lo has respondido perfectamente. Es Python y para la interfaz gráfica es PyQt3.
El Fortran es el estándar, ¿no? En este tipo de cálculos, porque Gaussian también está escrito en Fortran, ¿no?
Sí, más para la parte matemática, lo que nosotros llamamos calculador, ¿no? Efectivamente.
Vale.
Otra pregunta.
Más preguntas.
I see that you have many products and services, so I just wondering how many time takes to develop each programs in a specific, because it seems you have a lot. So
Yeah, it takes a long time. Too long, let me tell you. This is one of the biggest fights we have, how fast we go. It's been, even though the company was created in 2014, it's been 5 years of heavy development. And even then, we're still maybe halfway, Monica. So yes, it's very complex. Another thing is that we, as you can imagine, the profile of the skills that we look for in our team members are kind of a strange mix between a scientist and a programmer, which is the freak of all freaks, if you will. But it does take quite a bit. And this is one, it has been one of our biggest battles as a company, how to survive while we are obviously developing our products. And this is always trying to find equilibrium in doing projects and devoting time to the consulting side that will prevent us to spend time in actual development, software development. We are 12 people in the core team, and we have limited resources. So handling priorities, Monica knows better than anybody because it's one of her her duties here. But yeah, it takes a long time. We think that in another 5 years, we have completed everything we have in our roadmap. And I could share a couple more slides I have. I just try to, fit it to the time that we have today. But we do have quite a bit of functionality planned in our roadmap. And most of this functionality is driven by the feedback that the industrial clients gives us. Like I said, we then turn around and look at the scientific community and academia and see what the options we have in new theories and tools that are sometimes partially developed. We adopt them, we complete them, and then we put them, produce them in the context of industrial use. So yeah, too long, really.
Gracias.
I have a question. I was wondering about the competitors you have in the market. I don't know if there are kind of simulators and quantum mechanics and this, let's say, quite accessible looks like. Of course, I have heard about this before, but I don't know what about the world market, because you have clients in Japan, you said, and everywhere. So,
Right. Well, there's two sides. One is the competitors and the other one, the clients. Competitors, there are not too many. Unfortunately, the guys that are out there have been going at it for much longer than us. And as you can imagine, given that the target customers are large companies with lots of money that they're pouring into R&D, so the same can be said for the companies that provide the products. So for example, QuantumWise was acquired by Synopsys not too long ago. Synopsys is a huge company with thousands and thousands of employees. However, we do believe that, like anything else in any other market, there is a place for us. There's not too many of us. And so there is small market share for us would be, and it is, a complete success. So we don't have to become number one. We just want to play in the big leagues, and we're getting there slowly but surely. It's not too many competitors. You're right. This is, again, because of high power computing not being what it is today. 10 years ago, obviously, you won't find 50 companies out there that are doing just what we do. No, you might find 6, 7, 8, and that's about it. To be honest, in Spain, we don't have a single client. I don't think we've, Monica, is that correct? I don't think we have a single client. We have well over 150 companies in Japan that are clients of ours. Obviously, the US is a big market, and Europe in general, including Spain. But again, it is only, unfortunately, large companies that are willing to spend serious money into R&D, and obviously with that comes tools like ours. So that's the situation today.
Thank you.
¿Alguna cuestión? No, en principio en el chat. No.
Okay.
I have a question. Principal, the educational course is running already, or is a plan to run?
I'm going to let Monica take this one.
You're asking about ASAP Edo, the educational course. I mean, we are working on that, on this. We are talking with people as you to understand what are the needs that you have when you are imparting this kind of course. But the idea is to launch this project this year. So in a few months we can start offering the ISAP material course.
So very nice to see that.
Mm-hmm.
Yeah, one more thing I want to add to that. It seems that every university has a little bit different approach and objective. And we come to realize that probably the materials, even though it's not a lot of work for us, will have to be slightly customized to each one of the universities. And this is why I thought you guys might be also a good candidate to at least give us feedback. I mean, this is like any company. The first thing is what the market needs, what they want, and then turn around and produce products that resemble that. So good.
So I want to add something. So we have a draft of a list of the topics that we want to address in this course. We will be happy of sharing it with you. And
we have it ready today just in case somebody would ask that. So I guess then if you would like, I could share the screen and just to give you an idea.
Okay.
Let me just open it up here. And I'm going to share now. Okay, I want to share this one. Okay, so see if you can see my screen now. Okay. So, for example, these are different topics that we have. All materials are related. All materials related are not only tutorials, video tutorials, and how-to, but as well different configurations in their software that go along with these topics. The structure builder obviously is a very basic thing. How to set up a system for ab initio calculations, basic ab initio calculations, how to do them. Ground state properties, so EOS, thermodynamic properties, lattice, chemical, finite temperature elements and effects, van der Waals interfacial systems for friction and so on, magnetic systems, ferroelectric. These are more advanced, mind you, obviously. Electronic excitations for time-dependent DFT, transport, large-scale calculations, which do seem to get complex. So these are some of the ones that we chose to show you if you were to ask, as we thought that these might have been adequate for someone like you. So this hopefully gives you an idea of what we have in mind and how practical the courses that we prepare are. Again, these are complementary. By no means we mean to create an entire course strictly focused on this. This should be complementary, hands-on exercises that are going along with some of the topics that you have in your curricula for the academic year. So hopefully that gives you an idea of what it is that we have.
It's a very complete course. Very mindful.
Good.
Very nice.
Good.
Okay.
I have a question.
More question.
Another question.
Another question.
Since I'm an engineer, I think Atomistics can make a very good predictions on the materials, but they have the real materials, which are not always the same. Do you have any tool for going multi-scale simulation?
That's the question. I don't know. You want me to take it, Monica, or you want to take it?
You can start, and I can.
No, that's a great question. And, I thought a lot about how much I wanted to talk about this because this is the Holy Grail of nanotechnology. I think that we do have ASAP-Eng, as we saw in our presentation, is actually, that's actually the concept. I think that nanotechnology will strive in the next few years because of that. Macro scale tools, the engineering tools that are being used today for design and creation of products in any industry are limited to their own scale, as you can imagine. And upscale or multi-scale solution is definitely the place that we need to get to. Eventually we will. We all know we will. It's very complex from a software standpoint. So what we decided to do was to focus on specific industrial applications where we could take results from a nano simulation, properties, material properties, or catalytic reaction, any of the different angles that we showed you for our software, and bring them upscale into specific macro tools. Multi-scale as a generic all cure type of solution is very, very difficult. And a lot of people have been trying to do that for a long time. We're involved in some initiatives ourselves, but we decided to take a more practical approach. Is let's choose specific applications, specific challenges where precision and industrial production and design are limiting. And I think electronics is one of the better examples where lithography just ran out of what it could give. And now we're all looking into things like spintronics or any other solutions that can let us continue downsize in a practical way. So yes, we are working really, really hard on creating this product. And again, we don't dare say that our solution will be generically multi-scale, that anything you can feed today into our ASAP platform will be scalable, because the reality is not yet. But we could do, and we have identified specific applications, specific properties that we can bring into the micro scale tools that will actually make a difference in the outcome. And this is kind of a practical approach to that. So the answer is yes, but again, with some caution, as today we still are limited by many different factors. And I think even computing, high power computing today still is a bit of a limitation in that concept. Maybe quantum computing will resolve all that, but we're still some years away from that. So, Monica, you want to add anything?
Well, I can add that in the short future, so in our roadmap is to include in ASAP a calculator working in classical molecular dynamics. So in that sense, we will upgrade the scale. So it will complement siesta. So
because in principle, Gaussian is is the backend for the molecular calculation, and you are using siesta for the stem solid, for crystalline or solid, because you're not using Gaussian for bulk materials.
No, so in our product in ASAP we have only siesta as a calculator. Daniel mentioned Gaussian before because we are distributors of Gaussian, but it's like a separated product.
Okay. Because I don't know if Crystal software from UK. Mm-hmm. This people is using Gaussians instead of pseudopotential. Maybe this I think it's not competitor of Siesta, because Siesta is for large system, and the other people is more for probably a smaller system using Gaussians. And then I don't know why I was thinking, okay, these people is using ASAP like a front end to use Gaussian or Siesta, depending of the system that you are going to do the calculation. But it's my mistake.
No, I did mention that we're integrating ANT with Gaussian, but as Monica said, is a separate product. And now the workflow, exactly, does not play any part in that solution. It's just ANT and Gaussian together that will give specific approach to transport, to electronic transport problems. Yeah.
Okay. For if no more questions, we can finish. Here, the presentation. I'm waiting for the course. If you can, maybe here we can find beta testers. There's no connection.
Okay.
Can you hear me?
Yeah. I heard that. Yes, we'd be glad to get feedback from you guys and even participate in some sort of pilot if you think this could be valuable. Yes.
So as pilot, we have to identify where to.
Yeah.
In which specific, we go directly to the PhD students, the sector of PhD students. We can think of that. I'm looking at the face of Emilio, and it's like, wow, I really want to test it.
Okay.
So that's
okay. Thank you.
Okay. Thank you so much. Appreciate it.
Gracias.
Muchas gracias.
Thank you, gracias.
Gracias. La cámara no funciona.
No, ya. Y a ver si... Cierra.
Cerramos, ¿no?
Hola, pescado vendido.